Okay, so with these remaining slides that I want to cover, I'm going to skip around a little bit just to be able to make sure that we finish everything that we need to. So in talking about these last slides, we're going to be talking about the oligopoly. Now the oligopoly is probably one of the more difficult types of firms to follow. So you might want to make sure that you either look at the slides extra close or watch, listen to me talking about them multiple times. But for the oligopoly, we have a small number of firms, generally between 5 to 8 firms. There may or may not be product differentiation. So for instance, the airlines are an oligopoly, but there's not a lot of product differentiation. Automobiles, on the other hand, you could argue that there's a lot of product differentiation, but it is also an oligopoly. There are significant barriers to entry into this type of industry. They could be the patents, the technology that existed for the monopoly, but it also could be something like name recognition. And you could also engage in strategy to make sure that your competitors don't come in. So when we're talking about oligopolies, we're talking all about strategy and rivalry between the firms. And so what that means for us is that instead of drawing a graph, we really have to think about this in sort of a game theory behavior kind of context. And so firms are going to have to compete on the basis of price as well as on the basis of quantity. Right, so the way to kind of set this up would be if one firm decides to cut their price, what will the others do? This is what happens all the time with the airlines. Delta cuts its fare by $15 between 2 different cities. What will Southwest do? What will American do? Right, and this is dynamic. These games are played multiple times. Now, we're going to focus on duopolies. That means only 2 firms existing within that market. And we're going to focus more specifically on the Nash equilibrium. That means that each player is doing the best that they can, and then importantly, given what its competitors are doing. So this equilibrium will be stable. Firms are going to be doing the best that they can, and they're going to have no incentive to change their behavior. This Nash equilibrium is also a non-cooperative equilibrium. And so we're going to be looking at 2 models here. First, we're going to be looking at the Cournot model. In the Cournot model, the firms are producing a similar good, a homogeneous good, and they're going to treat the output of the other as fixed. But the firms are going to simultaneously decide how much to produce, based on one firm's output being fixed. So what we're going to have to do is we're going to have to create basically what are called reaction curves. The reaction curves are basically saying if firm 1 produces this, this is what firm 2 will produce, right? And in this model, we're going to assume that they know how much the other firm is going to produce. So they're not going to misestimate how much the other firm produces here. Now, these reaction curves, right, are also going to give rise to demand curves. So we're going to have, right, in this case here, we're going to have demand curves that are relevant to a different quantity of output. So if firm 1 produces nothing, then firm 2 will also produce nothing, right? But if firm 1 thinks that firm 2 will produce 50 units, right, then that's going to shift the demand curve to here, right? If firm 1 thinks that firm 2 is going to produce 75 units, they're obviously taking more of the market, right? Then, right, firm 1 is pushed down here. Now, keep in mind here, this is the price for good 1, quantity for good 1, for firm 1. What a reaction curve is a relationship between the firm's profit maximizing output and the amount that the other firm is producing. So as a reaction, again, it's saying this is how much I'll produce given what the other firm is producing. As the firm produces more, this firm should produce less. As firm 2 produces more, firm 1 should produce less, and vice versa. So the reaction curves actually look something like this. each firm has a reaction curve, and your eyes immediately should be drawn to that, essentially to that point of equilibrium, that point where they cross each other, right? What is this saying? This is saying firm 2's reaction function is saying this is firm 2's output as a function of firm 1's output, firm 1's reaction curve. This would be the quantity produced by firm 1 as a function of firm 2. Again, we're presuming that each firm is accurately predicting how much the other produces, and again, that point of where they intersect one another being called the Cournot equilibrium. This Cournot equilibrium would also be our example of a Nash equilibrium. It's a Nash equilibrium because it's non-cooperative. These are two firms that are individually trying to maximize their profit. It does unfortunately say nothing about how it adjusts to that Cournot equilibrium. We just basically presume that the firms are going to adjust their output, and that neither output is fixed. Okay, so if we want to look at how we would actually start to solve something like this, they're going to face a linear market demand curve. And so in this case, I will give you the inverse demand curve. In this case, P equaling 30 minus Q. Well, that Q is kind of like a big Q, because actually you can break down the two subfirms down into it, Q1, Q2. Now they're both going to, in this case here, have the same marginal cost. It's not always going to be the case, but in this case I'm going to have them facing the exact same marginal cost. Well, for firm 1, its reaction function would have to be determined by MR equaling MC, our classic profit maximizing equation. Well, revenue for firm 1 would be P times Q1. The P is actually coming from, right, this inverse demand curve right here, P equals 30 minus Q. But then you have to multiply it by Q1. So this right here, this 30 minus Q, is the equivalent of firm 1's price. But this Q is a big Q. It's the whole market Q. This then, so this is kind of like P1, this part in parentheses, and this is the Q1. Now notice what happens here as I go down one step here. I have to break down this big Q into two sub-Qs, Q1, Q2. And it's going to be multiplied by Q1. Right, so then as I distribute it out, 30 times Q1 gives me 30 Q1. Q1 times Q1 gives me Q1 squared. Q2 times Q1 gives me Q2 Q1. Then I take the first derivative of that function, right? This is my total revenue. Now I'm going to take the first derivative with the first order partial derivative with respect to Q1. That's going to leave me with 30 minus 2Q1 Q2. If I then set that equal to 0, which is the marginal cost in this case, and then I solve for Q1, I simply get this, Q1 equaling 15 minus 1/2 Q2. Now, you can already jump ahead and see firm 2's reaction function, because it's basically the exact same stuff, right? The exact same numbers, except you're just algebraically switching the Q1 into Q2. Okay. I know that's a lot, so you may want to pause it here just for your own sake to rewatch or to re-listen to that explanation. There's still more to solve though in this problem here. I then have to set my Q1 equal to my Q2, right? Because that is what a Cournot equilibrium is. If I do that, I then am going to solve for my Q. In this case, Q1 and Q2 are each going to be 10. That's going to equal 20. And then if I substitute that 20 into the inverse demand curve, right, then I'm going to get my price as 10. How does that look? It looks like this, right? I solved for each firm's reaction curve, and I found the equilibrium, where the price is, right, in this case, is set such that each firm is producing 10 units. This is Q1's output. This is Q2's output. Okay. Now, actually, let me let me pause it, stop it right here, and I'll make another video. I have to keep them under 10 minutes just to be able to put these on YouTube.